Hello and welcome back once again. We're coming to you from the auditorium. My name is Manny, and this is part of our multi-part series in statistics. So let's begin. This is presentation 405, and the topic is probability using combination permutations. Now we're going to look at a permutation first. A permutation is a specific ordered arrangement of a set. So starting with a set of 5 objects, we select 3, so we're looking at different ordered arrangements. And as you can see here, we just permute these or change these ordering to get a permutation. Now we're going to look at all the possible permutations. We have them coming on the screen here. If A is first, B is second, then we have these choices. If C is second, we have these. And of course we could have D and E with the same type of arrangements. And now, if we start with B, we have a similar scheme, and you see them coming on the screen here. And you should feel free to stop the video at any time and record these. Generally then, if we have 3 selections, we lay out 3 cups, if you wish, or 3 plates, and we put in the number of choices on the first, which in this case is 5. Once we've selected that, then 4, then 3, giving us a total of 60 possible arrangements. And this is given the symbol P5, choose 3. And so generally then, if we have n objects, we have n choices for the first, n minus 1 for the second, n minus 2 for the third, down, and so on, giving us, multiplying those out, we give us the total possible arrangements. And this is the formula for Pn choose R. Now we're going to pause the screen here just a second. So generally then, if we have 12 objects choosing 4 at a time, we set up 4 plates, and note the selection order or sequence here. We put in 12 down, and that gives us a total number of permutations. From 12 objects, choose 4, and there's the symbolic notation. And so we have, now watch what's happening here. We repeat that, get the same number, but we're going to extend it downwards. We're putting 8, 7, 6, 5, 4, 3, 2, 1 top and bottom. Now it's the same number, but this gives us the pattern. This top part is 12 factorial, the bottom part is 8 factorial. And we're suggesting that we want to arrive at a function here. The 8 factorial we're going to replace by 12 minus 4, which comes from the difference between these 2 subscripts here. And that is the formula for permutations, 12 choose 4. So generally then, P of n choose R, n factorial over n minus R factorial. And that's the formulation. Note coming on the screen here. Now we're going to look at a combination. Combination is a specific grouping. For example, ABC, ABD, BCD, and so on. So now we're going to look at combinations. Now look what we're going to do here. Now these are combinations. Once one is used, we can't use any of the other. We can't use it again. And we're coming up here. Pause the screen again. We find that there are 10 possible ordered arrangements. And you see them on the screen there. And we're going to try and arrive at a formula for these. Now look closely. We're going to permute each combination of 3, and they're coming on the screen here. And there's 6 ways to permute a given set of ABC in the following ways. So they're coming on the screen here. While they're doing that, pause the screen now. And now look closely. In this rectangular region, there are 60 possible ordered arrangements. So if we take the 60, that's the total area here if you wish, and divide by the permutations for each combination, we arrive at the number of combinations. Now there were just 5, 4, 3, that's the total permutations, but the number of representations there of one combination is 3, 2, 1, or 6, and that's why we divide, giving us the 10. And the so-called quick and dirty method, we simply put 3 plates top and bottom, put 5, 4, 3 on top, 3, 2, 1 on the bottom, multiply and divide, giving us the total. Now we're going to look at factorial notation. C of 12, choose 4. Watch closely now. We set up 4 plates, top and bottom. And on top, we fill in 12 down. On the bottom, we put in 4, 3, 2, 1. We multiply and we divide, giving an answer 495 combinations of 4 from 12. And looking at the factorial notation closely here, this would be, look closely, this total numerator here is 12 factorial, and the bottom part is 4 factorial times 8 factorial. And we have to explain this or write this in terms of the two subscripts, 12 and 4. And of course 8 is 12 minus 4 factorial. And so this gives us the formula, general formula of combinations of n and our objects from n. And here's an exercise, 7, choose 3. Now you should pause the screen here. We're going to put the answers on the screen for you to verify on your own. And this brings to an end presentation 4.5. We ask you to take notes and as required and review or go to presentation 4.6.